Hello again. We are continuing our discussion of exponents and exponential functions by talking now specifically about those exponential functions. So let's get started. I want you to think back to when we were talking about the first lesson and we had this table in front of us where we had different values of n, and those values of n were being raised as an exponent of the base 5, and this is the table we came up with. So that's fine when we're talking about learning about exponents and everything, but now let's change the headings so that we can start talking about functions instead, functions dealing with x's and y's. So my left column will be x's and my right column will be y's, and each of those y's is calculated as 5 to the x. All right, so when you add a constant amount to your x's, so going from the bottom of the table up to the top, when you keep adding 1 and then 1 and then 1, what's happening is you keep multiplying the y's by a constant amount. So multiply by 5, multiply by 5, multiply by 5. That's what exponential functions do. All right, so if you see that pattern in a table, you will know that you have an exponential function by adding constant amounts to the x's, but multiplying the y's by constant amounts. Okay, so let's look at the graph of what this looks like. 3 and 125, I can't really see that because the y value is too far off of my graph. So let's start with the coordinates 2 and 25. That point is right there. The coordinate, or the point 1 and 5 is right there. 0 and 1 is right there. Negative 1 and 1/5 is there. Negative 2 and 1/25 is there. And negative 3 and 1 over 125 is right there. So if I connect those points, it's not going to be linear. It's actually going to be a curve that kind of starts off pretty flat and then really gets steep really fast. So what are the properties of this function? Well, I notice that it actually, as I go to the left, it approaches the x-axis, which has equation y equals 0, but it never actually touches it. And that's because there's no x that I could plug in that would give me a y value of 0. Okay, so that means that y equals 0. We call that an asymptote. It is a line that the graph approaches but never touches or crosses. All right, the graph actually has, it also has a y-intercept of 1. That's where it's going to cross the y-axis. The domain is all real numbers. Every x can be used on this graph. But the range, because it is all above that y equals 0 line, the range is y is greater than 0. So we're going to talk about how those things change as I transform that function in different ways. If I shift it up and down, let's say I shift it up by 10, what that means is the equation is y equals 10 plus 5 to the x, or y equals 5 to the x plus 10. So now the asymptote that was at y equals 0 is now at y equals 10, so that has shifted up. The y-intercept is now y equals 11 instead of y equals 1. The domain is still all real numbers, but the range has now shifted. Now it is all y's greater than 10 instead of all y's greater than 0. So those three things, the y-intercept, the asymptote, and the range have changed, but the domain is still the same. Okay. Now let's talk about stretching it vertically. So now I'm taking y equals 5 to the x and I'm multiplying it by 20, and what that does is it stretches the whole graph. So the asymptote is still the same. That hasn't changed. It's still at y equals 0. The y-intercept, though, has gone from being 1 to 20, so it is actually 20 times bigger than it was before. The domain is still all real numbers, and the range is still y is greater than 0, so the only thing that really changed was the y-intercept because of that stretch, and everything else stayed the same. Now, if I reflect instead, that means I'm flipping it over the x-axis, so it is going down instead of going up as I go to the right. So I write that as y equals negative 5 to the x. Okay? The asymptote is still y equals 0. That hasn't changed. The y-intercept is now y equals negative 1 because that flipped over the x-axis as well. So it now has a negative y-coordinate. The domain is still all real numbers, and the range has now flipped, and it is now y is less than 0 instead of y is greater than 0. So the y-intercept and the range changed because of that reflection, but the asymptote didn't change and the domain did not change. Okay, so here's a real-world example of where I would use exponential functions. Let's say Karen wants to save up for a $1,500 vacation. What she does is she invests $800 at 6% interest, and that interest is compounded. Okay, will she have enough in 9 years? So here's what we need to do. We need to note that she has 6% more than she had each year. So I'm not really going to take that $800 and keep multiplying it by 6% because that makes it smaller and smaller and smaller. I need to think of it as her having 106% of what she had each year. She has 6% more, so add that onto the 100% or all of what she had before, and that is 106%. So I'm going to be multiplying by that 106% repeatedly as part of my exponential function. As a decimal, 106% is 1.06, so that's actually what I'm multiplying by. So I will take $800 and I will multiply it by 1.06 to the x because I keep multiplying by 1.06 over and over again. When x is 9, because of 9 years, I need to take $800 and I need to multiply it by 1.06 9 times, once for each year that has passed. And so that gives me $1,351.58, which is not enough. She needed $1,500, so she's going to have to save for a little bit longer or start saving earlier, plan her trip later. I'm not sure. But that is exponential functions in a nutshell. If you have any questions, please let me know, and I will see you tomorrow.